What's poppin', dogs? Mr. Allen here, calculating some surface areas in this video. Got a cylinder and a cone to work with, so we're going to be dealing with some circles here. But let's start it off with the cylinder. What is it made up of? Because for surface area, I just need to find the area of the surfaces and add them all up, right? With pyramids, it's like triangles and a square. With prisms, it's triangles, squares, rectangles, things like that. What do I got here? Well, I got a circle and a circle. So I have two circle bases. So my base, my area of the base is going to be pi r squared, but I have two of them. It's actually going to be the area of the base over here for the cone too. So we'll save that for a little later here. But what about the lateral area, which is what wraps around the cylinder? Well, I just so happen to have a wonderful handy dandy roll of Blue Shop paper towels, best kind of paper towels. Again, we can see that we have circle base, what up? But what wraps around? Well, if I unwrap this, what do I have? I have a rectangle, potentially a square, probably a rectangle. A rectangle is what wraps around this cylinder. Well, one of my dimensions is the 12 feet, okay, pretty darn close to this paper towel, not to scale. But what is the other dimension, this one that's up here, right? Well, didn't this come off of the paper towel roll? It was wrapped around it. What is this distance right here? That's my circumference of the circle. So let's jot down circumference as well. I'm going to put it over here because it's not necessarily one of the area ones that we're going to be using entirely, but we're going to use it in a mix of the formulas. So we have 2 pi r. That's my circumference of a circle. Pi times diameter also works. So let's go ahead and start with finding the area of my two bases of this cylinder. And I'm going to do the right work right here in the base of the cylinder. And when I'm doing this, I like to write area, like A, capital A, and then base as a subscript there, just to keep my work organized and I know like what I'm talking about, because you can get kind of messy here, especially when you're dealing with multiple surfaces. So I have pi times my radius of 4 right down here, 4 feet squared. So I get 16 pi. Now, when dealing with things like cylinders, cones, spheres, anything circular, we're dealing with pi, we often leave it in terms of pi. So we'll say 16 pi for one base. So for both bases, we'll do 2 times 16 pi. I'll do that down here. 2 times 16 pi, that is 32 pi. So our base area is 32 pi for both of them, okay? So area bases equals 32 pi. And we got feet, so feet squared, okay? So that is one of our pieces to this puzzle, but we want the total surface area. So we also have to find our lateral area. So here we can do lateral area, LA is a common one there. What is our lateral area again? It is, we said, let me get it, a rectangle, right? What's my formula for the area of a rectangle? It is length times width, or base times height. And those two dimensions were this height here of 12 feet and my circumference, which would be 2 pi r. So let's do that right now. We were going to have, I'll do it in here, lateral area. We'll put the final over here. Lateral area, I have 12 times 2 times pi times my radius of 4. All right, so height, length, whatever you want to call it, right? My two dimensions are multiplied together, this being my circumference, this being my height, right? So you can multiply them in either order. We're going to get the same thing. We have, let's see here, 12 times 2 is 24, times 4 is 96. So it'd be 96 pi feet squared. If you didn't like that, you could do 2 times 4 is 8. 8 times 12. 8 times 10 is 80. 8 times 2 is 16. Add them together, 96. Okay, it checks out. If needed, bust out this bad boy, plug it in the calculator. So now I have this for my lateral area, 96 pi feet squared. Let's add them together, right? That'll give me my total surface area. And I'll put my total surface area right in here in pink. We have TSA, not the security people, all right, at the airport, just TSA, total surface area, 96 plus 32, that's going to be what, 128? 128 pi feet squared. Boom. Final answer. And just to double check, and we'll do a little decimal equivalence here. This thing is, woo, there we go. Okay. We've got 96, hold on, my OS is validating right now. We've got 96 plus 32, 128 pi. So you can just add these like they're coefficients, guys. 32 plus 96, the pi stays at the end just like it was 32x plus 96x. You just do it like terms. That's it. Now, if I want to find out what the decimal equivalent is, I would just multiply by pi, hitting second and then the caret in your calculator, and we get 402.1238. So this one will be 402.12 feet squared. So that is an approximate. We put the squiggly equals for that for our total surface area. Cool. All right. But the usual preferred method in a math class is this guy. But if I'm like trying to apply it somewhere, I'm going to want decimals, right? I'm going to have 402 roughly feet squared for this surface area of this cylinder. If I'm building something, then for some reason I want the surface area of a cylinder. Going to go with decimals rather than in terms of pi. No one goes to the hardware store and says, can I get 128 pi square feet of paint? How many cans is that? No. You got to calculate it with that kind of stuff. All right. Onto the cone. Onto the cone here, guys. I'm going to go ahead and separate this. There we go. Okay. Now we have a designated working area. Cones. I got a circle. Okay. Circle is important. We already know that a circle is pi r squared. What about that lateral area? What the heck is that thing made up of? Is it a triangle? No, it's like curved. It wraps around. I don't even know if I could really make it for you guys with my paper. I don't have a cool paper towel. It's like a weird, I mean, imagine like we had New Year's hats. That kind of look. Anyways. All right. It's a separate formula. It is, and I'm going to go with LA, the lateral area is pi r L. What is L? That is the slant height right there. It's that slanted part. Now, we don't have that measurement right now. However, if you know your Pythagorean triples, and if not, it's okay. Maybe you haven't learned them yet. Maybe you have. If you haven't, your teacher will just give you these dimensions. 7, 24, and in this case, 25 inches, okay? 7 squared plus 24 squared equals 25 squared. That is my that is my slant height right there, which will help me calculate my lateral area, okay? So let's get to work. We got our base area. We'll do that we did it in blue before, so we'll do that again. Area of the base. In this case, there's only one circle, so it's pi times 7 squared, or 49 pi. Good to go there. And then we can do the orange for the lateral area. So lateral area is going to be pi times my radius of 7 times the slant height of 25. What is that, 175? Pi. I was thinking 25 times 8 is 200. Subtract off of 25. Let's just double check, right? I don't want to have a video on the internet and then make a mistake. It is 175. All right, cool. So if we add these together, 175 plus 49 is 224, 224. We'll put the TSA. Make sure we don't get it mixed up. TSA is 224 pi, and we're in inches squared. So there is my exact final total surface area. And if I want it as a decimal, I can multiply by pi second caret, 703.716. So 703.72 inches squared. Lovely. So for those of you that don't know, the double tick mark, that means inches. The 1 means feet. There's no short way of like being, like you can't do this. I can't say, let's see here off to this side here. I can't do 703.72 inches squared. You can't do that, okay? You can't square the abbreviated form, unfortunately, so you got to do the IN squared for your inches squared. Make sure when you're dealing with surface area, you're doing inches squared, feet squared. Your units are squared for surface area. When it's volume, they are cubed. If it's a length, they don't have that exponent. It's just feet, just inches, all that good stuff. All right? Thank you guys for watching here. We got a whole lot of math going on. Hopefully you enjoyed yourself some, cylinders and cones here. They are pretty darn dope. I always enjoy the good old paper towel, demonstration in there to show that it is actually a rectangle that wraps around our cylinder there, which is just awesome. So thank you guys for watching. Have a wonderful day. If you have any questions, pop them in the comments. Otherwise, stay dope.